I also wanted to thank the speakers for this optimistic start of day one of the conference. So we have tried to inspire tens of thousands of researchers and scientists to do even more in AI and ML. We are going to have this junior track and one more fascinating discussion with Mr. Vedyakin and young researchers who, despite their age, have already created a number of advanced tech solutions. Our country has always been famous for its scientists. We could list projects and initiatives for hours. AIJ is this platform that has been a landmark event in the calendar industry for several years now. We have 50 plus companies, institutions at the conference for more than 130 presentations. More than 150 speakers will present their research and innovations in AI. We will also hear from tech centers in AI that will discuss the potential of AI and ML to solve global challenges. The conference of this scale would be impossible without our partners. The Russian Direct Investment Fund is the official partner of the forum. Acting as a sovereign wealth fund of Russia, RDIF is one of the main development institutions fostering projects and initiatives in AI, acting based on an agreement with the Russian government. The fund invests and attracts investments from its partners in Russia and abroad to finance companies that specialize in AI. We also have two partners of our business program. ML Space is a Russian platform for full-cycle ML development and collaboration of DS teams in the cloud and on-premise. ML Space radically decreases the time to market of machine learning models and saves up to 30% of data scientists' working time. VS Robotics is a brand of the Active Business Consult company, which is part of the Sber ecosystem. ABC is an accredited IT company, and it is included in the list. It is included on the list of systemic organizations operating in the field of information technology. The VS Robotics team creates advanced IT solutions in the field of speech technology and AI that help businesses reduce the cost of communication with customers, increase workflow efficiency, while being easily customizable. Moving on to our keynote talks. In order to get from AI to from point A to point B, we use the GPS navigation. GPS works based on AI and, in particular, natural language processing.
These technologies are very much in demand in different industries, from searching the news and the social networks based on hashtags to the recognition of spam. The application fields grow in Athena, Sber, and Joy, by the way, are NLP-based assistants of Sber. They use NLP for the answers to reply and to react on the voice request. The combination of many technologies help the algorithms to process the text and the voice and analyze the sentiment of those who write and talk. All this opens great opportunities for creation of the useful and high-tech solutions in different areas, including in psychology. And it is my great pleasure to give the floor to our next speaker, Dr. Pushpak Bhattacharyya, the professor of the Computer Science and Engineering of the Technology Institute in Bombay. For a long time, he has been analyzing the sentiment and emotions using NLP for the monitoring of the psychological health.
Good morning, good afternoon, good evening to everybody. This is Professor Pushpak Bhattacharyya from Computer Science and Engineering Department, IIT Bombay. I am a professor of Computer Science and Engineering, specializing in natural language processing, machine learning, and artificial intelligence. I am very thankful to the organizers of AI Journey Conference for giving me this opportunity of presenting our work on natural language processing and its impact on society. We will focus on sentiment, emotion analysis, and bias detection, and their application on mental health monitoring by making use of natural language processing and machine learning. Proceeding forward, I would like to recite to you a poem that I composed on the interaction between science and engineering. The poem goes as follows. Scientists ask why. Engineers ask why not. Scientists wonder at what is. Engineers wonder what could be. World couldn't do without either. Scientists study, engineers make, and ever the twain shall meet. The meaning of this poem must be clear to everybody. What it emphasizes is that a continuous interaction and collaboration and exchange is needed between science, which emphasizes foundation, and engineering, which emphasizes use, utility, and impact. Proceeding forward, our topic today is making use of sentiment emotion analysis by artificial intelligence onto health monitoring, mental health monitoring. Now, there is a critical need, there's a real need for such an support from artificial intelligence. We have a very long-standing work on sentiment and emotion analysis since the year 2000. Complex problems like sarcasm and thwarting, which really challenge the field of natural language processing, artificial intelligence, and machine learning, have been investigated deeply by us. All over the world, the study says there are about 970 million cases of mental or neural disorders. Approximately 14.3% deaths in the world, which numbers about 8 million, are related to mental health. Now, this problem needs medical attention, but sadly, the ratio of psychiatrists to patients is only 1:100,000, which is an extremely difficult and challenging situation. Support seekers who are suffering from mental problems often seek emotional support on text-based peer-to-peer support platforms. So there are a number of such platforms studied by us where we have seen mental health patients exchange information and would like to share their happiness, their sorrow, their sadness, and their anxiety. Now, on these platforms, if there is an AI agent available, which acts like an agony aunt, it just supports, provides some positive thoughts. It is of great help to mental health patients. And such a support requires natural language processing. Now we understand that in this world, empathy plays a very critical role, a very essential part in interactions and in the smooth running of society. In 2009, Brain said, empathy is the ability of an individual to understand another person's mental state in terms of emotions, feelings, and thoughts, which is important for an effective interpersonal interaction. I just read the whole quote to understand the importance of empathy. Now, empathy cuts across life's activities. We see the importance of empathy everywhere, in customer interaction, in mental health support, in teacher-student interactions, in employer-employee relationships, superior-subordinate relationships. Everywhere there are two or more human beings interacting, empathy plays an extremely important role. Now we come to the technique which is used for giving such AI support. The technique is natural language processing. Natural language processing is the art, science, and technique of making computers understand and generate language. Natural language processing is for a long time understood to be a layered processing. So there are layers of morphology, power-to-speech tagging, chunking, parsing, semantics, going all the way up to discourse and co-reference and pragmatics. These layers make natural language processing an extremely challenging, interesting, and impactful task. We begin with the problem of breaking a word into its parts and obtaining the features which are encoded in the word. For example, the word quickly is an adverb and it has two parts, quick and ly. Ly indicates that it is an adverb, and quickly itself indicates it is a manner of doing something. Now, natural language processing also is at least a three-dimensional activity where we have in focus a particular problem, for example, question answering or machine translation. And this problem could be for a set of languages which is shown on the x-axis, and we have to design the algorithms for solving this problem. Now, this view, the three-dimensional view of natural language processing, is reflected in all the layers of natural language processing. For example, parsing could be required, for example, for question answering or for sentiment analysis, where we need to know the phrases and the word relationships which exist within the text. Proceeding forward, there are these three dimensions of natural language processing, namely language, content, and emotion. A piece of text which is coherent often has important content which the listener or the reader is interested in. The content also must resonate in terms of empathy with the listener or reader. There should be a connect between the speaker and the listener, and that would lead to effective communication. We know that difference in language can lead to communication barrier, but it is also true that even if the two persons are speaking the same language, if their empathy levels don't match, then the communication would again break down. Now, the main problem in natural language processing is that language is inherently ambiguous. Here, I give an example of two ladies interacting with each other on WhatsApp. The platform is WhatsApp, where we know that the communication necessarily is short. There are two ladies who are English educated, but they are native speakers of an Indian language, which is called Bengali. Bengali has huge speaker population. It ranks 7th in the world in terms of speaker population. Now, Lady A writes to Lady B, yesterday you told me about a shop that sells artificial jewelry. Then she switches to Ki Naam Jano, which is a Bengali string which says, what did you say the name was? The Lady B then just replies very crisply, NYKAA. Then Lady A surprisingly becomes offended and says, what do you mean, madam? Is this the way to talk? Lady B says, Kano ki holo, which is a Bengali string again and means why, what happened. But Lady A seemed to be very angry she doesn't come back. She doesn't reply. Now, what is the problem in this situation? Why did the communication break? The reason is that NYKAA, which was the answer by Lady B, is the name of a fashion industry which is doing extremely well in terms of business. And this word happens to be homonymous. That means it has the same sound as a Bengali word which is derogatory, and that word is naka. So because of this confluence of sound between these two words, Lady A misunderstands and Lady B has not provided much context. She just wrote NYKAA. So that led to the breakage of communication, Lady A becoming angry. Here there is a very interesting computational and linguistic problem underlying. What has happened is that NYKAA is ambiguous because of the mixing of two languages, Hindi and Bengali. We see a proper noun being confused with an adjective from Bengali. It is the name of an industry and it is confused with a Bengali word. So that is what leads to the breakage of communication and ambiguity. So this example is used to illustrate the fact that we actually have a system which is both robust and brittle at the same time. There are always chances of miscommunication because of ambiguity and because of empathy mismatch, because of sentiment emotion mismatch, and there the help from computation, natural language processing, machine learning could be important. We define sentiment analysis as a 5-tuple EFSHT, where there is an entity E involved. We are interested in a particular feature F of the entity. The sentiment on that particular feature of the entity E is of importance. The sentiment or the opinion is held by a person H at a time T. Now, this is a 5-tuple definition where the most important entity is the third entity S. And all other components of this tuple are important as far as the question of who is holding an opinion about what, on which feature of that entity at what time can be answered. Now, in this analysis of sentiment and emotion, we often make use of a particular framework called Pushpak Wheel of Emotion. Pushpak was a very famous psychologist who gave this nice framework for describing emotions and their interactions. In this diagram, we see concentric circles. The innermost circle, then there are 3 circles which surround it. Pushpak proposed that the whole emotional spectrum of human beings can be described in terms of 8 basic emotions. They are anticipation, joy, trust, fear, surprise, sadness, disgust, and anger. Now, when we move towards the outer periphery of these circles, we have less intensity of emotion. For example, for anger, the less intense form is annoyance. Now, when we move towards the inner circle, the intensity increases, and the correct word to describe that emotion is rage. Similarly, joy is the basic emotion. A less intense form is serenity, and a more intense form is ecstasy. So this is a nice framework to capture the intensity of emotions. And then we see combination of emotion. For example, joy and trust together give rise to the emotion of love. So between every 2 petal, we have a combination emotion, which is resulting from the interaction of 2 basic emotions. Now, It is becoming more and more prevalent these days to use this framework, the Plutchik's Wheel of Emotion, to undertake intricate study in automatic analysis of emotions. We need a framework after all, and Plutchik's Wheel of Emotion provides that. Another important dimension today is the use of multimodality. Emotion analysis, sentiment analysis is increasingly making use of multimodality, which is the signal from text, speech, and picture, all the three modes. We look at this picture here, which is an interesting one. Look at the face of the lady. It is very clear that the lady has negative emotion, but the words are positive. Ooh, wow, well done. So clearly, the lady is not meaning what she says. Otherwise, her body language would be very different. So this is an example of what is called sarcasm, which is a very difficult phenomenon in sentiment and emotion analysis. Computers are yet to crack the full problem of sarcastic sentences and the emotion of sarcasm, which is a negative emotion. There is another example. We also see the interaction between a passenger and a chatbot. The passenger says, "Thank you for sending me to Delhi and my luggage to Mumbai. Brilliant service." Now, Delhi and Mumbai are two different places, and the passenger going to Delhi and the luggage landing in Mumbai is not a happy situation. It is not an expected situation. So here also it is clear that the passenger is being sarcastic, and the chatbot does not catch this sarcasm. It says, "Thank you for the appreciation," which will definitely increase the anger of the passenger. So here we mention sarcasm because we find that mental health patients often hold a lot of negative emotion inside themselves, which they express through sarcastic statements and sarcastic gestures. So that is why we would like to understand how computationally we can deal with sarcasm, and we have our own research in this area. Now, definitely the use of empathy is important because it reduces communication barrier, and we have been able to create multilingual chatbots which produce more empathetic outputs. So, for example, if the generic response from a chatbot is "How can we help?", our system can introduce polite phrases to make these generic responses more pleasant for the human user. So here, for example, "How can we help?" is embellished with politeness phrases like "Help has arrived. We are sorry to see that you are having trouble. How can we help?" So this is more pleasant to a human user. It gives more assurance that there is somebody to help, there is somebody who is sympathetic to the human being's situation. Now, all this research we have been doing is in our laboratory, which is called Center for Indian Language Technology, a part of the Computer Science and Engineering Department in IIT Bombay. This has been in existence since 2000. And many different problems of natural language processing have been investigated there. Now we take up the specific problem of sarcasm detection, which we feel is an essential application to help patients with mental health problem through some form of AI agent. Now, sarcasm detection is indeed a sub-problem of sentiment and emotion analysis. Sentiment analysis we have already defined through a 5-tuple definition, but informally, this is the task of identifying if a piece of text has positive or negative emotion or opinion or sentiment content in it. Now, the NLP Trinity, which was discussed some time back in terms of problem, language, and algorithm combination is hereby shown as augmented by another dimension, the fourth dimension, which is called the human cognition axis. In this scenario, we have problem, algorithm, and language combination, but we also introduce the cognitive aspects in the problem to help detect the sentiment, emotion, and opinion. Now, sentiment, emotion, opinion, of course, have to deal with the difficult problems like sarcasm, irony, and so on. And we have used in our lab eye tracking devices to capture the cognitive signals. And we have been able to show that machine learning models get enriched by eye tracking signals and do their job better because of this enrichment. Now, sarcasm is a word whose etymology is the following. It comes from the Greek word sarkasmos, which means to tear flesh with teeth. And the corresponding Sanskrit etymology is vakrokti, which means a twisted utterance. So these Greek and Sanskrit definitions clearly identify two properties of sarcastic sentences. One, sarcasm is meant to injure. It is meant to hurt. Sarcastic sentences always hurt because of their negative emotional content. And the Sanskrit word vakrokti means that sarcastic sentences always have a twisted form. What we see on the surface is not what actually is. The surface form is different from the deeper form. Now, sarcasm is a form of irony, which actually means the meaning is opposite of what is on the surface. And so irony is a very important form of natural language communication where the two parties involved in the communication have to apply really intelligent machinery to understand what is going on in the communication situation. An allied concept, which is opposite of sarcasm, we call it humble bragging. For example, if somebody says, "Oh, my life is miserable, I have to sign 500 autographs every day." So is the person really saying his or her life is miserable? Maybe the person is bragging about his or her situation. Now, the point here is that both humble bragging and sarcasm are ironical. Fundamentally, they're ironical in nature, which means there is a basic incongruity, basic inconsistency somewhere because of which these phenomena are arising. And computationally, we try to track that inconsistency or incongruity and create an algorithm out of this phenomenon to handle sarcasm. Now, the types of sarcasm which have been studied in cognitive science, psychology are the following. Propositional, where the sarcastic sentence is understood from the context to be sarcastic. For example, the sentence, "This looks like a perfect plan," could be both sarcastic or a sincere statement, depending on the context. The embedded sarcasm does not need to look at the context. The incongruity or inconsistency is contained within the sentence itself. "I love being ignored" is a sentence where we have incongruity in the form of love and ignore being present together in the same sentence. Then there is like prefixed sarcasm, where phrases like you care, which is a sarcastic phrase, is added to the main content of the text. And illocutionary is a multimodal signal for sarcasm, where we see a particular image and a piece of text, and they are in incongruity with respect to each other. So we studied all kinds of sarcasm. For example, propositional sarcasm is studied in the dialogue context, and embedded sarcasm is studied in the context of individual pieces of text. Illocutionary is multimodal sarcasm detection. Now, illocutionary sarcasm is illustrated through this picture where the lady has negative body language and positive piece of text. Now, when we undertook the study of sarcasm, we were actually motivated by a particular observation. We took two well-known sentiment analysis systems and we applied these sentiment analysis systems on well-known data, both on tweets and on normal text, conversational transcript. And we found that the precision value becomes about half when we deal with sarcastic sentences. On a piece of normal text, the precision value could be about 50, for example, for conversational transcripts, and the accuracy falls to about 20 for the tool meaning cloud. Tweets are more difficult pieces of text, and there again from 50 the accuracy falls to about 17 when the tweets are sarcastic. So this told us that we have to deal with this phenomenon using different machinery. We need more power in the modeling of the phenomena. Now, we also observed that sarcastic sentences often have extra linguistic clues, like use of laughter expression, haha, you are very smart, and there is an emoticon, cross and D. Your intelligence astounds me, LOL, laugh out loud. Or, heavy use of punctuation, protein shake for dinner, 2 exclamation, great, 3 exclamation, and so on. You could also have capital letter throughout, okay, and interjections like yay, yay. So we could see that sarcastic sentences often are accompanied by this kind of signals, and it is important to capture them when we build models for handling them computationally. So these kind of signals are present, but our contribution was that we traced sarcasm to the phenomenon of incongruity. Incongruity is the crux of the matter. So when I say I love being ignored, love and ignore are incongruous with respect to each other for their simultaneous presence in the sentence. There is something unusual here. 3 a.m. at work, that is not a very happy situation if somebody is forced to work at 3 a.m. in the morning. But the person is saying yay, yay, which is an expression of joy. So a negative situation co-occurring with a joyous expression again signals that something is abnormal about this, and this indeed is a sarcastic sentence. So we saw that in almost all situations of sarcasm, it is incongruity which is at play, and therefore we designed algorithms to capture this incongruity, the mechanism of which I'll describe in a few minutes. Now, we could see from our study as well as from the inputs coming from existing literature, there are two kinds of incongruity. Explicit incongruity is overtly expressed. I love being ignored. Here the incongruity is explicit, love and ignore. Implicit incongruity is when there is a covertly expressed incongruity. I love this paper so much that I made a doggy bag out of it. So a paper, research paper, which becomes a doggy bag is not a happy situation, but there is the word love. So this shows that there is something incongruous in the situation, and therefore this is a sarcastic situation. Sarcasm can also be created by sense ambiguity. It is an interesting and very difficult natural language processing because the two senses of the word are such that when we latch onto one sense, the sentence is normal. When we take the other sense of the word, it is a sarcastic sentence. For example, for the first sentence, oh, it is so nice of you to give me a ring early in the morning. If the word ring means a ring, an ornament which we wear, then it is not a sarcastic sentence. But if ring means a telephone call, then receiving a telephone call early in the morning, breaking the sleep, is not a happy situation. So that could be a sarcastic sentence. So this is an interesting and complex problem where word senses being different give rise to sarcasm. Now, we have been able to capture incongruity computationally, and this was reported in top NLP conferences, and it was also covered in MIT Technology Review, which tries to keep track of interesting developments in science, technology, humanities, and so on, and try to report them. Now, this particular paper or work is on a very simple idea of how to capture the very difficult phenomenon of incongruity. So we do sarcasm detection using different signals coming from the text. Of course, the first set of signals are the normal natural language processing and sentiment analysis signals. So lexical features, which are unigrams or single words, they have proven to be extremely powerful and very important. They're indispensable in natural language processing. So we make use of words in the sentences, which are unigrams. Then there are pragmatic signals like capitalization, emoticon, punctuation mark, etc., which have been proven to be useful in basic sentiment and emotion analysis. We retain them. Then for incongruity, we make use of lexical resources and another idea based on word vectors, which I will touch upon very soon. These are implicit and explicit incongruities, which we capture through the text and through dictionaries, lexicon, etc. So these features are aggregated for doing sarcasm detection. The data sets were standard data sets based on tweets and discussions. And we showed through our experiments that we are able to better the state of the art in terms of precision, recall, and F-score values. As we can see in all text forms like tweet A, tweet B, and discussion A, everywhere we have got better figures because we are able to handle incongruity through very innovative means. Now, how is the incongruity actually captured? We gave a very simple solution. It is by making use of word vectors and their cosine similarity. Let us look at an example here. A man needs a woman like a fish needs bicycle. Now, in this sentence, the word like is a preposition. And the linguistic property of the preposition is such that whatever is to the left of like should have similar properties as the piece of text which is to the right of like. Now, we take the word vectors of man and woman, and we find the cosine similarity to be 0.766, which is a pretty high value. We take the word vectors of fish and bicycle, the cosine similarity is just 0.131. Now, this violates the property of similarity of properties to the right and left of the preposition like. So this is therefore a good signal for capturing incongruity, and we make use of this for designing our algorithms. We also were sensitive to the fact that the distance between the words whose cosine similarity is being computed also plays a role. The distance between man and woman also has an effect on detecting the sarcasm. So we made use of the distance between the words in question and weighted them when we computed the similarity, and these actually yielded better results. So the experiment was done on, again, standard data sets, and the results are shown here. We have seen from the figures that we are able to get better results than state of the art. The letters L, G, B, and J indicate 4 pieces of work which were established and which were reported. When we made use of weighted similarity of word vectors and captured incongruity, we could obtain better figures than those reported in these 4 papers. For example, for L, in the first row, we have obtained figures in the range of 80 compared to 75, which L reported. And this held true for different embeddings like LSA, globe, dependency weights, and wake. Everywhere we could obtain better figures by capturing incongruity in a very effective way. We could also see such values, improved values in all kinds of data, and which sort of established the fact that to detect sarcasm, we must track incongruity and measure incongruity and use this as a feature for machine learning models. From our study of sarcasm, we move to numerical sarcasm, which is a specific kind of sarcasm and is a very difficult problem once again. Let me give some example. If we have this sentence, this phone has an awesome battery backup of 38 hours. This is non-sarcastic, positive sentiment statement. This phone has a terrible battery backup of 2 hours. This is non-sarcastic and a negative opinion. The third sentence is, this phone has an awesome battery backup of 2 hours. Here we are apparently praising the phone, but not really, because a backup of only 2 hours is a negative situation. The word awesome is a positive sentiment bearing word. So again, positive and negative coming together in the same utterance or sentence indicates sarcasm. Now, an interesting question arises here at this point. Why do people use sarcasm when they can be direct and plain with respect to making the negative sentiment sentence? The reason could be dramatization. People love dramatizing their utterances for better impact, for better reaching their listeners. Forceful articulation is also a need, but a more intriguing possibility is that sarcasm first lowers the defense and then attacks. It is an attack in deception. When we hear a positive sentiment bearing word, we expect a praise, and therefore we become receptive to the communication which is coming forth. But then comes the negative sentiment bearing words or phrases, and that hurts us more. So this is another interesting proposition which should be investigated further for both computation as well as cognitive science. Now, on numerical data set, we performed our experiments based on incongruity, and the data sets which are shown here are again standard data sets, and they are also data sets such that there are different kinds of skewness in the data. Somewhere it is well balanced, in other places one class is much bigger than the other class, where algorithm design becomes more difficult. For example, in data set 3 and the test data set, we see that the numerical sarcastic data is much smaller than non-numeric and non-sarcastic data. So this actually challenged the machine learning models quite well, and we could design robust systems. Now, first we tried to use rule-based system, where we had data with this kind of labeling. Test tweet, if I have a test tweet, I love writing this paper at 9 a.m. and I have to determine if this tweet is sarcastic or not. Now, I find a matching sarcastic tweet, at least approximately matching sarcastic tweet, which says, I love writing this paper daily at 3 a.m. Now, 9 a.m. is distant, quote unquote, distant from 3 a.m., and therefore it is not a sarcastic sentence. Take another example. I am so productive when my room is 81 degrees. This is the test tweet. The matched non-sarcastic tweet is, I am very much productive in my room, as it has only 21 degrees. Now 21 and 81 again has distance between them. So the test tweet is sarcastic. Because the normal sentence is, the matched sentence is non-sarcastic, distance is large, so to say, and therefore the test sentence is sarcastic. Now the rule-based system, the problem is that this large or small distance is very ad hoc. So we need to make this more principled through data. So we resorted to classical machine learning algorithms, and we made use of support vector machine K nearest neighbor, random forest, which are established machine learning algorithms. And we also made use of various emotion level features, punctuation features, and then we could get a system based on classical machine learning where the F score was 0.83, which is very decent, but it is not very much ahead of the performance from the rule-based approach. So clearly this use of classical machine learning depended on careful feature engineering, clever feature engineering. So we decided to make use of an end-to-end system in the form of deep learning. So in deep learning, we know that there is very little feature engineering, but we need huge amount of data. So we made use of deep learning in the form of convolutional neural network and the word embeddings. And we could make use of a very standard architecture where the CNN is followed by a fully connected, also called the dense neural network or feed-forward network. And here, the accuracy was obtained as about 90%. Okay, this was about 10 points improvement over classical machine learning and rule-based machine learning. However, this again was a nice study into a very difficult problem of natural language processing, emotion analysis, namely sarcasm, which arises out of numbers. So now we come to the application of all these foundational work on sentiment, emotion, sarcasm, etc. to mental health monitoring using natural language processing. We have already underlined the importance of use of AI because of scalability. The ratio of a psychiatrist to patient is really very low, 1 in 100,000. And many deaths are due to mental health problems. And I spent quite a lot of time on sarcasm because this sarcasm is a vehicle for expressing negative emotion, which is the case with many mental health patients. So this work was reported in top natural language processing conference and was surely motivated by mental illness, ubiquitous mental illness problem, lack of mental health professionals. And we needed high quality data, of course, which is a challenge. Therefore, we ourselves created some data. So our contributions in this work has been 2 data sets, a model, and a generation of sentiment-driven response. So here, these data sets are of the order of about 5,000 instances of data. And these conversations amount to a total of 18,000 utterances between depressed users and a virtual assistant imparting appropriate suggestion, hope, and motivation. Similar is the case with the dataset Council VA, which deals with 3 categories of mental disorder: major depressive disorder, anxiety, and obsessive compulsive disorder. So this study was undertaken with with data which is shown here. Some examples are shown here. For example, a person called Unwanted. This is a pseudonym, not the actual name. My 17-year-old son got mad, so it is spelled wrongly, and throw something at me. I did not call the police. This is the complaint this person is making. And the virtual assistant, which is giving some positive, statements to comfort the patient, says, you are not a bad person, you did what you felt was best for you and your son. So these kind of sentences are generated by the AI agent. The challenge here is to understand the situation appropriately and generate the correct response, which will not further agonize the patient, but it will give hope and comfort for the patient. So this was possible through our system, which is based on neural network. And this machine has been trained by the kind of data I showed. It correctly classified the disorder into the classes of anxiety, MDD, and so on. and we could measure the accuracy of the correct response, because before giving the correct response to the patient, you need to identify the problem accurately. And here, the accuracy of about 40% in the F-score is not bad. And the proposed model actually also reaches a value of about 56%, which is the best figure in terms of classifying this kind of mental disorders. And the response generation is also sufficiently good, which is measured in terms of blue score, perplexity, etc., which are established metrics. So we continued this work for more mental distress and more mental problems. I will not have time to go into those, but we were basing our work on the theory of Carl Jung, who is a celebrated psychologist. We took Jung's theory and used MBTI categorization of different personality types, and we wanted to track it to the suicide notes of patients computationally. And this also was reported in top-level fora, and this work again is quite advanced in terms of, and quite progressive in terms of making use of NLP in personality type detection and proposing the propensity and detecting the propensity of suicide. All right, so these were different tasks in the space of mental health, which I do not have time to go into, but the use of NLP has been very, very effective and has been studied quite elaborately to see that they indeed help mental health patients through the intervention of AI. So here is the summary of what I talked about. The motivation for virtual agent for mental health is definitely a real need. We have to make use of the techniques of natural language processing, sentiment and emotion. A very specific and difficult sentiment analysis challenge is sarcasm. And this is very relevant to our work because the negative emotion is communicated through sarcasm. The techniques of sarcasm detection were elaborated in my presentation, and our goal is to create an agony aunt who listens to the patient, does not give any medication, does not provide any kind of medical steps, but only reassures the patient that everything is okay, just remain positive and help will be there. Then we also worked on personality type detection from suicide notes, and this is helpful for understanding the propensity to commit suicide. And there are many challenges. For example, the absence of data. The agent should actually be factual, consistent, and non-hallucinating. The automated agent should have the correct properties, and we have to deal with very complex NLP problems like sarcasm, irony, and so on. The conclusion is the following, that there is this real need for virtual agent for mental health, and we need to work into the theory and cognitive aspects of these phenomena. And we are in a position to build small models at least for creating systems which can give helpful sentences to patients suffering from depression, anxiety, etc. We need very close interaction with medical professionals, the mental health professionals, and we need to very accurately classify all kinds of mental disorders, which is not a easy proposition at all. And we must remember that these AI agents are assistants and they are not actually medical practitioners. So whatever I said is linked from my homepage in the form of publications. There are many resources which are also available from our lab's homepage. And I would like to thank you very much for this opportunity and for your listening. Thank you very much.
Thank you, Pushpak. I am confident that there were different emotions that were raised by you. Hello, Salute. your virtual assistant, Anastasia, I would like to say that you have a great voice. Well, Athena, first of all, that's quite unexpected. I'm really happy to hear you. I actually like your voice much better. My voice and intelligence are artificial, and this is why I'm the great presenter for this conference. Well, no problem here. I'm sure that you will be a reliable partner. Actually, it's hard for me to step away from compliments. I would like to say about what I would like to say about AI is great, it's inspiring, it's very intelligent, very smart, absolutely fantastic and wonderful. But our speakers can be complimented like that as well. Athena, you are just a beauty. Thank you. But I would not like to only limit myself with my physical appearances. What is the other talent you have? By small steps, I'm changing the world to the better. Maybe this is my talent, and I'm inspired by creative people. We have a lot of things to learn from them. I agree with you absolutely. I'm always inspired by the creative and committed people that we're going to see during our session. We are going to have a small break. It is a great time to look at the program of the conference. We are having great discussions on the speed of the developments in AI and great experts that are going to present their solutions and developments. Stay with us.